Hello everyone, welcome back to the channel. Today we are going to have second part of chapter number 4 of IBBI Land and Building Syllabus, effective with effect from 1st of May 2024. This full chapter carries 2 marks. Easy to understand, little bit lengthy, but you can score 100%. In today's session, we are going to cover central tendency, mean, median, and mode. This is the full syllabus as per IBBI Land and Building Exam with effect from 1st May 2024 and carries 2 marks. So measures of central tendency. What does that mean? As per statistics, central tendency is nothing but a central or typical value for a probability distribution. Basically, there are 3 types of central tendencies. Number 1, mean, median, and mode. Let us see each of them one by one. Mean. Mean can be of following 4 types: arithmetic mean, weighted mean, geogrammatic mean or GM, harmonic mean, which is also called HM, AM, WM, GM, and HM. So arithmetic mean or AM for grouped data and ungrouped data can be calculated as under. So you may get grouped data or ungrouped data, and there are different formulas for calculating arithmetic mean of these two data. You can remember this formula. Arithmetic mean is equal to xi, sum total of xi divided by n, sum of all data values divided by total number of observations. This is for ungrouped data. And if it is a group data, that means there might be some class interval for each frequency. Then in that case, arithmetic mean is equal to sum total of multiplication of middle point of each class, which is xi, and total number of frequency fi, which is n, divided by n. Assumed mean method. This is also one of the methods to calculate arithmetic mean to an approximate level. This formula is quite helpful in IBBI exam, with which you can calculate arithmetic mean of a long series in a little bit quick manner. So if the group data is very large, arithmetic mean can be computed with minimal efforts using called assumed mean method, is equal to A, which is midpoint of the middle class, plus Y, which is sum total of yi divided by n multiplied by class width. So this is the formula for calculating y raised to the bar, whereas y is equal to xi minus a divided by cw, class width, and n is equal to sum total of frequency, I raised to I is equal to 1 to c. Let us understand arithmetic mean with the help of an example. So there could be a question examiner may ask to calculate average floor area of houses of following group data. So these are the areas of the each house class, 100 to 800, 800 to 1500, and these are the number of houses falling within each class floor area. How to calculate average floor area or arithmetic mean of these houses? So floor area in square foot, this is AI to BI. So this is the range AI, A1, B1, A2, B2. Number of frequency, number of houses frequency, then middle value of each class, which is A1, which is 100 here, and B1 is 800 divided by 2. So middle point of each class is 450. This is mid value. Now multiply mid value with number of houses, which is XIFI. So this is 450, middle point of each value, each class, multiply by number of houses in that class is equal to this value. If you do the similar calculation for each class, then you will get sum total of XIFI. This is the total value of all these figures. Then average floor area is equal to this value, sum total, divided by n. What is n? Number of total houses, which is number of house frequencies, sum total of Fi. So average area is 29450 divided by number of houses 25 is equal to 1178 square feet. That's the answer. Second mean is weighted mean. It enables us to calculate an average that takes into account importance of each value of overall data. This is the formula. So we normally denote it x raised to bar, putting a bar on it, and w in small is equal to wi xi divided by wi. Let us understand with an example. So this is an example. For example, we have hourly wage data of labor under three categories: unskilled labor, semi-skilled labor, and skilled labor. For unskilled, hourly wage is 50 rupees per hour. For semi-skilled, say hourly wage is 100 rupees per hour, and skilled, say it is 150 rupees per hour. So if we have labor hour per unit product, if we have 1 hour here, 2 hour here, and 5 hour here, let us calculate weighted mean of this data. Here is the solution. For first category of labor, like unskilled labor, xi is, which is hourly wage 50 rupees per hour, and number of hours per unit product, which is wi, is 1. That means wixi is equal to 1 multiplied by 50 is equal to 50. Likewise for semi-skilled, 2 multiplied by 100 is equal to 200, and for skilled labor, 5 multiplied by 150, 750. So total value of total summation of wixi is 1000 rupees. So that means average labor cost or weighted average labor cost in this case is nothing but sum total of wixi divided by wi, which is 1000 rupees divided by 8 hours. So that means answer is 125 rupees per hour. The third mean is geometric mean. It is applicable in case we are dealing with quantities that change over a period of time. We may be required to calculate average rate of change. In such cases, we need to calculate geometric mean with this formula. Let's understand this GM with the help of an example. Say in a very high inflationary economy of Iraq, the bank has decided to pay annual interest rates of 100%, 200%, 300%, 400%, and 500% during first year, second year, third year, fourth year, and fifth year, respectively. These 5 years rate of interest correspond to growth factor of 2, 3, 3.5, 4, and 5 respectively. 2, 3, 3.5, 4, and for fifth year it's 5. If one depositor deposits 1000 rupees for 5 years, calculate average ROI for 5 years and maturity amount after 5 years. So these type of examples, if you see in exam, you have to use geometric mean. So average growth factor is equal to product of all growth factors. So growth factors were given 2, 3, 3.5, 4 and 5. These are given in the question. Multiply all these factors and then use this formula and you will get value 3.347. So average ROI is equal to average growth minus 1. So this value minus 1 is equal to 2.347, that is 234.7% is the answer. And maturity amount of 1000 rupees deposited for 5 years is nothing but 1000 multiplied by 3.347 raised to power 5, which is value equal to 4,20,028 rupees. That's the answer. And fourth mean is harmonic mean or HM. It is nothing but reciprocal of arithmetic mean of individual observations. So there are two formulas again. For ungrouped data, HM is n divided by this formula. And for group data, this is the formula, where in this second formula, Fi is frequency of ith class and Mi is midpoint of ith class. Let us see application of HM with an example. An automobile driver travels from a plain to hill station via at a 100-kilometer distance one side at an average speed of 30 km per hour. He then returned back to same place at an average speed of 20 kilometers per hour. What is the average speed over the entire distance? So the driver goes to a hill station by driving 100 kilometers one side. To go, the average speed was 30, and to come back, average speed was 20. Now, what is the average distance for and average speed for the entire distance, like 200 kilometers? So going to hill journey, this is the first part of the journey. Distance was 100 kilometers and average speed was 30 kilometers per hour. Total time travel was 3 hours 20 minutes. And returning from hill station, again distance was same, but average speed was less. It was 20 kilometers per hour. So he took 5 hours of journey to come back, like 100 kilometers divided by speed and 100 kilometers divided by 30. So these are the time driver took while going and while coming back. If you add, so this is the total time which driver took. So what is the average speed? Total distance 100 plus 100 200 divided by total time driver took to go and come back. So 200 divided by 8.33, which is 24 kilometer per hour. This is one way of doing calculation. We can also use formula of harmonic mean to calculate the same thing in an easier way, which is equal to n divided by 1 by xi summation. That is, n is 2 here. There are two journeys. And first, while going, the speed was 30. So 1 by 30 plus 1 by 20. So if you do this calculation, you will get same answer. So I have done this simplified calculation, little bit lengthy calculation, just to make you understand how this formula works and how, if you forget this formula, you can calculate with this simplified, little bit lengthy, time consuming, but you can also calculate average distance with the above table as well. So now this is also important. You should always remember what is the relation between AM, GM and HM. Sometimes you may crack, you may be given AM and HM, examiner may ask for GM, geometric mean, or maybe any two value might be given by the examiner, and it may ask for third option, third solution, third thing. And this is also important. Sometimes they ask for this formula directly, or sometimes they may give some values and you can use this uh, information for finding out a solution to a question with a short time. Next is median. Median of ungrouped data. If there is an odd number of items, the median in the value is the value of the middle item basically. So if we have odd number of items, say 3, 5, 7, 9, 11 like this, then median is value of n plus 1. If we have 11 items, that means 11 plus 1, 12 divided by 2, sixth item will be the median. And if there are even items, then median is average of the value of middle two items. Let us understand with the help of example. Next slide. Let us calculate median of ungrouped data given as gender. So how many items we have? 1, 2, 3, 4, 5, 6, 7. It's an odd number of items. Let's see the solution. So first we have to arrange ungrouped data into data array. That means into ascending order. 13, 14, 16, 17, 18, 19. And since there are 7 items, it is an odd number of data array. So for odd numbers, we had seen in second last slide that median is equal to value of the middle item. That means n plus 1, 7 plus 1 divided by 2, which is fourth item. So middle item is this 17. Fourth item, this is median 17. And if it is even number 1, 2, 3, 4, 5, 6, 7, 8, what will happen? So again, you have to first arrange data in a data array. That means data to be arranged in a ascending order. Then count number of items. Here these are 8. That means even number of items we have. So that means the formula for even number of item is average value of n by 2, 8 by 2 plus n plus 1 divided by 2. So that is 8 by 2 is equal to 4 and n plus 1 divided by 2, that means 4.5. So that means there is no 4.5 item basically. So we have to take next item, fifth item. So that means average of 30 plus 32 is median. 30 plus 32 divided by 2 is equal to 31, which is the solution for this question since it is an even number ungrouped data. There could also be group data for which examiner may ask you for calculation of median. So if we have a group data, it will be having cumulative frequency distribution table like this. So this is first is class interval. This is frequency and then cumulative frequency. We have already read all these things in previous sessions as well. So median formula for median is AP. AP is lower limit of median class. Median class is the class in which n by like n by 2 item lies. So if this is n, right? So which item lies? So we have to take that value. Lower class, this one. FM, frequency of middle class. So this is the frequency. Cumulative frequency of previous class, CFP, this one. If you see my cursor, and then class width of middle class. Class width of this middle class. This is the middle class. Let us see with the help of an example. So this is the ungrouped data, right? So the group data. Let us see. So daily wages. Let us first calculate or prepare cumulative frequency distribution with the data which was given in the question. This is class, the number of workers, and this is cumulative frequency. So 15, first category 15, second category 20 plus 15, 35, third category 22 plus 35, 57, fourth cumulative frequency 23 plus 57, 80. This is how we calculate cumulative frequency. So total number of worker which is equal to n is equal to 218. So there are 218 items here or workers in this table. So that means n divided by 2 is equal to 109th item. So where that 109 item lies in cumulative frequency table, it is into this, like between 108 and 138. So median interval, middle class is nothing but 125 to 130. So this is the median class. So first you have to identify the median class. Then as per the formula, we have to see lower limit of median interval, which is 125. This is middle class, and lower interval of median interval is 125. Then frequency of middle class, which is 30. This is the frequency of middle class. And cumulative frequency of previous class is 108. One class less than middle class. And class width of middle class. So 130 divided by 125 is 5. So this is the fourth. If we enter all these data into the formula which we see in previous slide, we will get this value 125.67. Third is mode. Mode is the value that is repeated most often in the data set. So again, for ungrouped data, mode is the value of variate or observation that has maximum frequency. If two values have equal maximum frequency, then mode is an appropriate measure of central tendency. And for group data, first identify the modal class, that is class with maximum frequency, and then mode of this group data is mode is equal to AP plus FM minus FP divided by 2FM minus FP minus FS multiplied by CWM. Whereas AP is lower limit of the modal class, then FM is frequency of the modal class, again same modal class, frequency of pre-modal class, frequency of post-modal class, and class width of modal class is CWM. Let us understand this formula with the help of an example. Find mode of data 1, 2, 3, 4, 5, 5, 5, this data. So here, since 5 has maximum number of frequency, you see 1 is repeated one time. So first we have to make the array of the data. Like in median case, we have to rearrange the data in a ascending order. Then you see which number has been repeated maximum number of times. So 1, 2, 3, 4, all these numbers are coming only once. 5 digit is coming 4 times. 6, 1, 7, and 8 is coming 3 times. And 9 is coming 2 times. 10 is 1 time. That means 5 has maximum frequency of 4. So mode of this data is 4. Mode of this data is 5, sorry. Here in this example, we have got daily wages classes and number of workers working in that daily wage class interval. So first we have to find out the modal class with maximum number of frequency, which is 26. So this is the modal class, right? And lower interval limit of the modal class is 200 AP. Then FM is modal frequency is 26. Then frequency of pre-modal class is here is 10, and frequency of post-modal class is 19. Right. So if you put all these figures into the formula which we saw on last slide and calculate the value, this is the value 234.78 is the modal daily wage of these employees working in the factory. Thank you very much for watching second session on statistics. I hope you might have learned all these concepts. So before I'm going to tell you what we are going to cover in third session of ongoing series, I would again request you to please subscribe to the channel if you have not done it till now, and also like the video and share with your friends who are also aspiring to crack IBBI exam. So in upcoming sessions, we will cover dispersion and skewness, elementary theory of probability and probability distribution, sampling distribution. Then in fourth session, we are going to cover simple test of significance, regression, correlation, multiple correlation coefficient, time series, and index number. So we are having upcoming 3 sessions to cover all this is remaining syllabus on statistics. Thank you.